panel. How do you obtain the solar panel? You see, we are still not yet done. Why did I mention so? Look at it. We only consider power, quantity, power factor, and the rating. We still have remaining portions, which is what? Hours of operation and the energy demand. So now, each given appliances, considering the hours of operation, for the ceiling fan, we consider 12 hours. So whatever you have here from the inverter rating here, you multiply by our hours of operation. And mind you, this inverter rating is in VA because power is a product of what? Current and voltage. And current is a unit, unit is what? Ampere. And the voltage is volt, which means VA is a rating to this. So as such, since we are multiplying by the hours of operation, it will become VAH or WH. W stands for power. VA also stands for power because P is equals to IV. So as such, we have option here. Either we write 3600 VAH or 3600 watt hour. Anyhow we do it, remain the same. Do we understand? Okay, what are we supposed to do here for us to get the solar panel? Since we are through, you sum all the energy demand together. This plus this plus this. How do you obtain all these values? 300 times 5 will get 150. 18.75 times 3 is 56.25. 312.5 times 5 to the end. Okay? So we are going to clear the board so that we do the calculation for the remaining components. Okay? So I'm going to clear the board. Okay, I think let us do it this way. Component number 1, inverter is equals to what? 3.5 kVA of what? 24 VDC. Okay? Okay? Or let me take it so that we maintain the space. Inverter is equals to 3.5 kVA of what? 24 VDC. Number 2, panel. Okay, how do we calculate the solar panel? Can you remember the energy demand obtained? Give me the value. The energy demand obtained, because we have to use it to what? To calculate the remaining components. There is what we call performance ratio, 65%. There is what we call peak sun shine hours. Okay. Then the energy demand. What do we have for the energy demand? The energy demand, all the inverter rating multiplied by the hours of operation. When we sum them all together, that is our what? Energy demand. Okay, we call it total energy demand. For a given appliances, it's just an energy demand. But when you sum all the energy demands, it will give us total energy demand. So what do we have for the total energy demand? Okay, can you remember? You see we have 7302 39, okay, 0.2.9 VAH or WH. Okay, so since we have 7,302 0.9 VAH. For us to get solar array power, we say, you see, total energy demand, okay, times performance ratio divided by peak sunshine hours. What is this performance ratio? Performance ratio is obtained, when the intensity or solar radiation or solar light or solar intensity coming from the sun reaching us here, it is estimated that 35% is lost before reaching us here. So out of 100, we are getting the remnants of what? 65% or 0.65. Okay? So as such, here in the performance ratio, we take it as 0.65. Then peak sunshine hours, we said we have 5 hours. Of course, we are starting from when? When we are going to experience high intensity is from 10 a.m., 10, 11, 12, 1, 2. At 2, that is when you are going to get the maximum solar intensity. Anything after 2, it will start what? Declining from 3, 4, 5, 6 downward till sunset, right? So which means our peak sunshine hours is what? 5 hours. So here we say, okay, total energy demand, which is what? 7,302.9 point what? 95, okay, VAH, or let's say W watt hour, okay, times 0.65 divided by 5. We have 5 here, okay? So now we do the calculation. This times 0.65, this is also in what? In hours, because we normally consider time period in hours. So since we have watt hour here and hour here, hour will also cancel hour here, which means we are left with this and this, only the values, because we're after getting the what? The number of solar panel required. Okay, so since that is the case, we'll say, okay, 7,302.95 watts, okay, times 0.65 divided by 5. Okay, what do we have? This times this, what do we have? 7,302.95 times 0.65. What do we have? We have 4,746.991. Okay, 917. We can approximate it here. We can have 4,747 here. Okay, 0.7. Okay, because we have a large number. Okay, divided by 5. What do we have? 949.38. Okay, watt, because of this W. So now we go to the market, look at the solar panel available in the market. We have 100 watt, we have 200 watt, we have 250 watt, we have 350 watt, we have 480 watt, we have 580 watt, we have 640 watt till 1000 watts. So now we look at all these panels that is available in the market. Mind you, we know our system voltage is what? 24 volts. As such, we have to get a panel that is above 200 watts. A panel below 200 watt is always 12 volts. Okay? Because this, if you look at the VOC to this panel, you have either from 17, 18, 19 to, let's say, 23 volts. But for this, you have the VOC of, let's say, from 30 to, let's say, 35 volts. Today, 1000. So any panel above 200, of course, it is what? System voltage is 24 volts. But any panel from 200 downwards is what? 12 volts. So as such, we are to select a panel between 200 downward, of what, sorry, 200 or 250 or 350 or 480. So let's take this 350 watt solar panel. We say divided by 350 watts. Since we are after getting the exact number, this watt will cancel watts. We are left with only digits. So now, what do we have? 949.38 divided by 350. What do we have? 3? Okay. 2.7. 125. Okay. Numbers. But mind you, we don't have a panel of decimal points. As such, we move to the nearest available solar panel, which is what? 3 numbers of 350 watt panel. So here, for the panel, we say we have 3 numbers of what? 350 watt. Of course, is what? 24 VDC. Do you see it? From the appliances, we are now moving to knowing the components. Okay, so these 3 numbers is just a minimum. The higher you go, or the more number of panels you have, the better or the fast charging you will have. Your battery will be fully charged. Number 2, you can use the solar panel directly in the daytime to power your home appliances, while your battery will be what? Serving as what? A fast. Your battery will be fully charged within the shortest period of time, and then the remaining hours you utilize the solar panel to power your appliances. That is to say, if you have more number of what? Solar panels, right? But if you restrict your own design based on what you have, this is a minimum number. 3 numbers of what? 350 watt solar panel. Okay, so now we are done with what? Solar panel. Which company is the next? The battery. Before the battery, let's go for the what? Charge controller. This is in a situation whereby we consider 350 watts. How about if we take, let's say, 250 watt panel? Let's do the calculation. What do we have? Okay, this is for 350. Let's do for the 250 here. 474, okay, sorry. 949.38 W divided by 250 W. This will go with this. What do we have? 3.797. Okay, numbers. Okay, approximately we have 4 numbers. Do you see? The bigger or the higher capacity panel you are selecting, the lower the quantity. The lower the quantity, the capacity of the panel you are selecting, the more number of panels you are going to get. Initially, when we select 350, we obtain 3 numbers. But by taking 250, we obtain 4 numbers.